my name is Ismi. My match number is A202387.
Hi, Assalamualaikum. My name is Muhammad Iqmal Bertatrai with matrix number A201811.
Hi, my name is Siti Nur Subaida binti Mardis and my matrix number is A203767.
Hi, my name is Nur Izzah Zuhaira binti Mahidin. My matrix number is A203781.
Hi, my name is Hanis Alisa binti Muhammad. My matrix number is A202945.
Hi, my name is Hana Amira binti Muhammad Hafiz. My matrix number is A202672 and today we'll be talking about Profenofos in fresh orange juice sold in night markets.
Introduction to Profenofos. Profenofos is an organophosphate insecticide and acaricide widely used in agriculture. It is primarily employed to control a variety of pests on crops such as cotton, maize, and vegetables. So, what is Profenofos? The chemical name for Profenofos is O4-bromo 2-chlorophenyl-O-ethyl asprosyl. The chemical formula for Profenofos is as follows. Typically, Profenofos exists as liquid with pale yellow with garlic-like odor. Profenofos is also corrosive. Common uses of Profenofos. Profenofos commonly found at vegetables and fruits, including tomatoes, potatoes, onions, citrus fruits, and grapes. Profenofos also found at cotton, which is used to control pests such as bollworm, aphids, and whiteflies. The use of Profenofos poses several environmental risks, including water contamination. Profenofos can seep into groundwater or run off into surface water, leading to pollution of water bodies. This contamination can harm aquatic life and may enter drinking water supplies. Furthermore, Profenofos can also affect human health because the indirect environmental exposure can also threaten human health, particularly for agricultural workers and nearby communities. Potential health issues including neurological problems, respiratory issues, and other chronic issues. Furthermore, Profenofos can also harm to non-target species. Profenofos is toxic to many non-target species, including beneficial insects like bees, birds, fish, and other wildlife. This toxicity can disrupt ecosystem and harm species that naturally control pests. Last but not least, Profenofos can also have impact on soil health because the chemical can negatively affect soil microorganisms, disrupting soil health and fertility over time. This disruption can impact plant growth and soil biodiversity.
For sampling method, we use convenience sampling because it allows for quick and easy sample collection. It also allows to collect from readily available sources such as vendors at the night market. Next, we move to method for collecting sample. First, collect fresh oranges from a night market using a clean and sterilized sampling bottle to prevent contamination. Secondly, shake the sample bottle to ensure the uniform distribution of any Profenofos residue. Thirdly, keep the sample chilled to prevent microbial growth and degradation of Profenofos residue. Lastly, submit the fresh orange juice sample to the laboratory for Profenofos residue analysis using suitable analytical methods.
Hi, Assalamualaikum. Today, I'm going to present about RP-HPLC method. So, what is RP-HPLC method? Reverse phase high performance liquid chromatography is a variant incorporating high pressure pumps and automated metering units to change the gradient of the mobile phase, providing a fast and a high resolution separation. The separation mechanism depends on the differential distribution of the organic components between the liquid mobile phase and solid stationary phase. In general, HPLC gives accurate result with non-ionic materials, but it can be also used to separate ionic compound by using the reverse phase method. Next, are there any other methods? Yes, there are. The method is gas chromatography. Gas chromatography is a term used to describe the group of analytical separation techniques used to analyze volatile substances in the gas phase. One of the sole forms of chromatography that does not utilize the mobile phase for interacting with analyte. In gas chromatography, the components of a sample are dissolved in a solvent and vaporized in order to separate the analytes by distributing the sample between two phases, a stationary phase and a mobile phase. The mobile phase is a chemically inert gas that serves to carry the molecules of the analyte through the heated column, while the stationary phase is either a solid absorbent termed gas solid chromatography (GSC) or a liquid on an inert support termed gas liquid chromatography (GLC).
So, what are the differences between RP-HPLC and GC for Profenofos detection? RP-HPLC is best for analyzing non-volatile, moderately polar compounds like Profenofos without the need for derivatization. GC is best for volatile and thermally stable compounds that needs high-resolution analysis. Next, RP-HPLC is easy to use since it requires an easier sample preparation for aqueous samples such as orange juice. Meanwhile, for GC, it requires more technical expertise due to the need for derivatization and the complexity of sample preparation. Lastly, for detection of Profenofos, RP-HPLC has more flexible detector options and suitability for complex matrices. Meanwhile, GC is highly sensitive and specific, especially with advanced detectors like mass spectrometry (GCMS). For the detection of Profenofos, RP-HPLC is generally more convenient and user-friendly due to its compatibility with the compound's properties and simpler sample preparation. GC might be chosen for its sensitivity and speed if the necessary derivatization and preparation steps are appropriately managed. What are the materials needed for RP-HPLC extraction? First, we need chemicals. So, the chemicals involved are solvents, standards and reagents, and sample preparation reagents. For solvents, we need acetonitrile, HPLC grade, which is used as an organic solvent for the mobile phase. Water, HPLC grade, which is used as an aqueous solvent for the mobile phase. And methanol, HPLC grade, which is sometimes used in the mobile phase or sample preparation. Next, for the standards and reagents, we need Profenofos standard, which is a pure reference standard of Profenofos for calibration and quantification. Extraction solvents, which is a mixture of acetonitrile and water or other solvents used for extracting Profenofos from orange juice. And formic acid or acetic acid in HPLC grade, which is often used to adjust the pH of the mobile phase or extraction solvents. Lastly, for sample preparation reagents, we need sodium chloride, which is used to help with the phase separation during the extraction process, magnesium sulfate, which is used as a drying agent in the extraction process, and lastly, C18 solid phase extraction (SP) cartridges, which is used for cleanup and concentration of the extracted Profenofos. The next thing we need for RP-HPLC extraction are equipments. The first equipments are the HPLC system. As you can see in the picture, first you need solvent reservoir to hold mobile phase solvents like water. Next, you need HPLC pump to deliver the mobile phase at a constant flow rate. Injector is used to introduce the sample into the HPLC system. HPLC column is a reverse phase column, typically C18, which is suitable for separating Profenofos. Lastly, we need a detector, which can be UV vis detector or diode array detector (DAD) for detecting Profenofos. A mass spectrometer (MS) can also be used for more sensitive detection. We also need other equipments for RP-HPLC extraction, which are sample preparation equipment and general laboratory supplies. For the sample preparation equipment, we need centrifuge for separating the different phases during sample preparation. Next, we need vortex mixer for mixing samples and solvents thoroughly. Rotary evaporator is used for concentrating the extract by evaporating solvents. Ultrasonic bath is needed for enhancing extraction efficiency by sonicating the sample. And lastly, we need vacuum manifold for use with SPE cartridges to facilitate sample cleanup. For the general laboratory supplies, first we need glassware, which are beakers, flasks, graduated cylinders and pipettes. Micropipettes are used for accurate measurement of small volumes. Next, we need filtration units, which are syringe filters for filtering samples before injection into the HPLC. Next, we need sample vials. Sample vials are HPLC vials with caps for holding samples to be injected. Analytical balance is needed for weighing chemicals and samples accurately. pH meter is needed for measuring and adjusting the pH of solvents and samples. And lastly, we need protective gear, which are lab coat, gloves and safety goggles for safe handling of chemicals. Next is the mechanism of RP-HPLC. For this part, you will have to pay attention to the video presented. In reverse phase HPLC, mobile phase is polar and the stationary phase is non-polar and hydrophobic. The silica in the column is modified to make it non-polar. Typically, 8 to 18 carbons are added to the silica, also known as C8 to C18. The silica C18 is non-polar. The non-polar molecules binds and adsorbs to it, and the polar molecules will pass more quickly through the stationary phase.
So, equipment 2 is gas chromatography. We have carrier gas. Function is typically helium, nitrogen or hydrogen used to transport the sample through the column. Next, we have injector. To introduce the samples into the GC system, a split or splitless injector is commonly used. Third, oven. Oven maintains the temperature gradient for separating the components in the sample. Next, column. Capillary column, often a non-polar or moderately polar columns, for example DB5 or equivalent, suitable for pesticide analysis. Last but not least, we have detectors, which are electron capture detector, ECD, and film photometric detector, FPD. ECD is highly sensitive for halogenated compounds like Profenofos, and FPD is sensitive to phosphorus and sulfur containing compounds, which is suitable for Profenofos. Next is comparison between GC and HPLC instrument in terms of recovery rates, separation efficiency, sensitivity, specificity, and analysis time. As for recovery rates, GC can be high but may vary due to complex sample preparation steps. Efficiency in sample preparation is crucial for consistent recovery, while HPLC often high and more consistent due to less extensive sample preparation process. For separation efficiency, GC capillary columns with high theoretical plate counts provide excellent separation efficiency, whereas HPLC C18 columns used in RP-HPLC provide good separation efficiency for non-volatile and moderately polar compounds. For sensitivity, GC generally higher than HPLC, capable of detecting very low concentrations of Profenofos. However, HPLC is sufficient for most regulatory limits but lower than GC ECD or FPD. Net specificity. GC have high specificity due to the use of selective detectors like ECD and FPD, while HPLC is good, especially with PDA detectors that provide spectral information. Last but not least, for analysis time, GC can be relatively short with efficient temperature programming, whereas HPLC can be longer, particularly with gradient elution methods.
All in all, scientific agrobiotechnology's advancement has its own pros and cons, such as insecticide that are effective against a wide range of insects that can help increase the worldwide agriculture yield by helps protect crops from damage and loss from pesticide. However, at the same time, bleeding the environment slowly, such as contaminate the water that can harm the aquatic life and water drinking system. Moreover, uncontrolled usage of Profenofos could negatively affect the soil health that can lead to contamination crops. GC and HPLC method of extraction plays a big part in this case. For comparison, from the point of accuracy, GC has high specificity due to the use of selective detectors like ECD and FPD. Meanwhile, for HPLC, provides spectral information. Furthermore, GC took short period of time to analysis, meanwhile HPLC required a longer time period. Although excessive usage of Profenofos has its own environmental issues, there is always room to mitigate the issue. First and foremost, apply proper application techniques such as by using a precision spraying equipment to target a specific crop to protect it from infested, rather than using a wide range spray to avoid unnecessary usage of Profenofos. Lastly, spraying Profenofos during windy or rainy season can lead the pesticide to drift and affected other areas. By implementing these strategies, farmers effectively control pests while minimizing the potential harm that can affect the environment and crops.
Do you have any questions?
That's all from us. Thank you.